First, gentlemen and ladies, start your robots. So you're thinking about sending more robots like the Mars rovers to other planets in the future. Where might you find up-and-coming designers and engineers today? Maybe here at Lower Merion High School, where the 6-year-old Technology and Engineering Club is inspiring kids with the right stuff to learn robotics. Mark Piotrowski is the tech teacher and club advisor.
We've grown from about 10, 12 students our first year to approximately 85 students. And we compete regionally at the state level and nationally in TSA and in FIRST Robotics.
After they get this one, like, tag your patches off, grab the next one and bring it down.
Oh, somebody out there is thinking TSA is the oldest national student organization for technology, grades kindergarten through 12. Rich Cresley, an English teacher and advisor, is a big fan of FIRST.
It was founded by Dean Kamen, the entrepreneur and inventor from New Hampshire, inventor of the Segway and other such things. He invented the competition, the first competition about 16 years ago, to excite kids about science, technology, engineering, and math.
But beyond the nuts and bolts, the computers, and the remote control, there's Katie Cooper, a math and computer science teacher, does a lot of observing because
the kids really run themselves. They coach themselves when in the actual competition. They maintain the machine, and I'm just there as a cheerleader advisor. One robot's name is Fluffy, but watch out, Lower Merion's team name is Dawgma, whose mission is more about problem solving and the process more than the actual winning with the machine and parts.
How are you using your skills and knowledge? How are you using them to embetter the people around you?
The idea that they're building a team, they're building life skills.
And put on a good show at the competition.
Student team members take us on a tour of Fluffy.
So we start within the dimensions of 18 by 18, and during autonomous mode, our tower lifts off. Then we go around the field picking up balls with the tread system. We have 4 motors, this black things right here. 1 motor for each wheel, but we geared them up with both sides of the robot, like 2 wheels per, like 2 motors for 2 wheels. So we had efficient turning, and we have a tread system with zip ties and a ramp to help the balls go into our whole tread system that sucks the balls all the way up. Once we have enough balls, we go to the high goal and start dumping them in.
What about those rubber bands?
And that's where we put the rubber bands to give it more force to be able to shoot them out.
We figured out during the autonomous period we still had an extra 8 seconds to play with. And so what we did is just figured out there's an extra pile of 4 balls right behind us that we could take and just turn right into the goal for another bonus 4 points that would help us win autonomous.
People with very diverse backgrounds, along with the technical skills, along with the interest in robotics, can really go a long way. Everything from government contracts to starting their own businesses to being in education.
There's just so many areas that the kids can get into. For VEX, not only can you build the machine, there's also people who take pictures. We have websites. There's drawings they can do. There's notebooks they can make. There's really, basically you can find a strength that you have and incorporate into some part of VEX and FIRST.
In this program, we focus primarily on technology and engineering, but the science and the mathematics is infused into the big picture. And we're very fortunate to have co-advisors who are certified in science, mathematics, technology, English, and also engineering.
They started in September 2006, putting in almost 6 months of hard after-school work.
Well, for the small FAC robot, we spent days brainstorming and talking about different possibilities and building prototypes. And we probably went through over 100 different ideas, and then at least 6 different prototypes before we settled on the final design. And with the larger FIRST Robotics competition robot, that's the same thing. It took weeks of designing and brainstorming and bouncing ideas off of each other, and also testing different pieces of equipment before we settled on something that could work.
Finally, Dawgma entered the Diamond State FVC Championships at the University of Delaware, January 2007.
not only we were surprised we won the regional, but to make it even better, our team won the Inspire Award, and that's given to a team that not only exceeds consistently well in competition, but it's also for a team that exemplifies gracious professionalism and has an ability to communicate with other teams as well as the judges.
And they qualified to go to the Nationals in Atlanta, Georgia in April. This year, the club built in 6 weeks a large robot called Deuce, plus a computer animation and a digital design program, all entered in the 2007 First Robotics Competition at Drexel University, March 29th through the 31st.
With the number of team members we have, we accomplish a huge amount throughout the school year.
Robotics provides another kind of exercise.
The brain as a muscle needs to be exercised, and when you look at these types of complex problems, you need all these different kinds of thinkers. And one of the best things about a robotics team is that when you bring all these different kinds of thinkers together and exercise those muscles in different ways and share with one another, certainly a student who takes to the team approach there will come out the other side, no matter how good the robot is, they'll come out the other side a better thinker.
Go Dogs!